this is our demonstration of the Bentley Ottmann line sweep algorithm. We have also represented its extension called Polygon self-intersection detector. Now this dialog box gives me an opportunity to choose any number of line segments. So let's say if I go on with n is equal to 7, I can generate any number. If this is the random selection of line segments I consider, I can start with the algorithm. So first of all, this is a left event in which the line S3 it will be inserted into the status queue, which is a dynamic event queue. Next, we move on to another line called S5. Now, as soon as we enter here, S5 will also be checked with its neighbor, which is S3, for any intersection, and we can see that they also intersect at a point of 369.64 and 426.12. So this particular event of intersection will be scheduled but will not be executed yet. Next is another left event, and again we see an intersection. So the intersection between these two lines will also be scheduled. Now this is an intersection event. So what happens in an intersection event is that those two lines which are intersecting, their sequence will be swapped in the event queue. So initially we found that 3 and 5 were intersecting, so later on they will be swapped and 5 and 3 will be there, and all the rest of the neighbors will be checked again. So 6 and 5 will also be checked for any intersection. Next, another left events, intersection event. So another swap will happen here. And now this is the right event. So what happens in a right event is we move towards the end point of a line segment. In that case, that particular line will be removed from the status queue. So S3 will now be removed from the status queue, which was because we've reached its end. So a similar algorithm will run for all the different lines in which we'll be finding out their intersection with their neighbors in the status queue. As soon as we find an intersecting point, we'll be swapping those two lines in the status queue and checking the rest of the neighbors. Upon finding a right point, we'll be removing that line from the status queue. So this is the end of our sweep line algorithm. Let's move on to a different, you can say, instance. Let's say if I take n is equal to 20 and I generate a very random set, and now I try to simulate the algorithm. So again, it's doing the same left events, all these different left events, and the right event of line S11 is there. But again, since it did not intersect with anything, it will be similarly removed. We have a lot other intersecting. Now this particular intersecting point, it was scheduled earlier over here, as you can see. So again, we are swapping S16 and S19 and the status queue, and again we'll be checking the rest of the lines for any intersection that might happen. So the same algorithm will run for n is equal to 20 and for the rest of the lines. As you can see, we are also recording all the different intersecting points and the order of increasing abscissa, and we are removing the line segments as soon as we find out their ending points. So the sweep will go on just like that, and all the different intersecting points have been labeled over here. Now this is our last event, and the status event queue is empty. We have removed all the different line segments and we have recorded all the intersecting points. So this is the end of our sweep. On with the next implementation, which is an extension of this algorithm called Polygon self-intersection detector. So this is the dialog box that opens here. We have given the user the ability to draw any sort of polygon with any number of lines. So this is how I can draw a random polygon over here. It can be a closed polygon, an open polygon. And as soon as I'm drawing over here, I can also see that the different vertices are being added with the respective points. So now this is the polygon that I have made. Let's say if I'm done over here, now what this algorithm is doing is it's going to find out whether the particular polygon is a closed polygon and if it has any self-intersecting edges. Now what is the difference between the two algorithms? In a normal Bentley Ottmann line sweep algorithm, any two lines that are intersecting, that particular point is considered as an intersecting point. But in a normal polygon, even the vertices will be considered as intersecting point. So here in this algorithm, the exception is that the vertices will not be considered, but any other two edges which are intersecting, they will be considered for an intersecting point. Now, as soon as I click on check polygon, the line sweep algorithm runs over it with the modification. And this is the line sweep algorithm. So the different line segments were inserted. We have the scheduling of intersecting points. We have the removing as soon as we reach the right side or the right event of the particular line segment. And at the end of the time, the status queue is empty. All the different line segments are removed, and we find out the different intersecting points with their particular x and y coordinates.